All right, moving on to nonlinear inequalities. So absolute value inequalities. Remember, we've done absolute values before. You must use the number line method. Okay, this one's a must, just like we did with the other absolute value problem. So absolute value inequalities. Find your critical points by setting the absolute value quantities equal to 0. Arrange your critical points on the number line in order. And then, of course, use the number line method that we've discussed in our previous sections. Okay, so again, for these next 3 problems, they must be done this way. Okay, so here we go. Where is the critical point, the critical number? Well, it's going to be the vertex of the V. So set x minus 3 equal to 0, and you're going to get that that occurs at 3. All right, so I'll draw the entire number line. Draw the entire number line and indicate that it goes on forever. So there's your arrows. You've got your V, right? Because the absolute value looks like a V. So there's the graph. And you know that critical point is happening at 3. Now, like we started doing on the last ones, let's test that critical point first, and then both sides will do our same process that we've been doing, okay, for absolute values. So here we go. If we plug in 3 first, 3 minus 3 is 0, absolute value of 0. Is 0 greater than or equal to 6? And it is not. So 3 does not work. Go back to labeling the absolute value. So on the right-hand side, the x minus 3, since this is a positive slope, if you thought of that as y equals x minus 3, that would be on that side. And the opposite of x minus 3 would be on this side, because if you distributed that, it'd be y equals negative x plus 3, and that would be a negative slope. All right, you are now breaking this into 2 regions. Remember, anything on the, when you replace this in exactly the same order that this is, just like it was last time, replace the absolute value on the left of the V with the equation on the left. This one, that expression, I should say, and anything on the right side in this region with what's on the right side, that right expression. Okay, so should be review if you need to go back and watch any of the other videos. But here we go. Replace it in that same order. So you're going to have the opposite of x minus 3 is greater than or equal to 6. And on the right side, you'll have x minus 3 is greater than or equal to 6. Go ahead and solve both those inequalities. So negative x plus 3 greater than or equal to 6, negative x greater than or equal to 3. When you divide by a negative, don't forget to switch the sign, less than or equal to negative 3. And then x is greater than or equal to 9 on this side. Now, remember, the lovely thing about the number line, okay, is that it does the checking for us as long as you know how to word it for yourself. So this is important enough that I will go ahead and write it over here for yourself, for you guys, and I would do the same thing in your notes. So the wording for testing regions needs to be the following. Are there values of x? Are there values of x in this region that are ... Okay, that's the wording you got to be able to say to yourself. And by that, I mean the following. So here we go. If I am looking at this on the left, I'm asking myself, are there values of x in this region, meaning to the left of 3? Are there values of x in this region that are less than or equal to negative 3? Well, yeah. Here is negative 3. Are there values in this region that are equal to it and less than it? Yep. I am giving you a graphical representation of that up on the number line. Okay. Once again, if I go on to the right-hand side, looking at this, I need to be able to ask myself, are there values of x in this region, meaning from 3 to the right? Are there values of x in this region that are greater than or equal to 9? Well, yeah, 9 is in this region, equal to it is here, greater than it is to the right. So now I can go back and just depend on the number line as showing me my answers, which will, of course, be intervals. Okay, so I'm going to have x equals from -infinity to -3 to -3, including it, so bracket, and from 9, including it, to infinity. Okay, there we go. All right, the next one. So you could manipulate, just so that you understand, you could leave that equation exactly as is, okay, and you'll get it right. But if you really want to isolate the absolute value of x minus 5, just so you understand that you are allowed to manipulate it as long as it's not incorrect. If I divide both sides by 2, this would now be less than 2. So I would go about still drawing my entire number line. My critical point is at 5. I will go ahead and put my V on here for the absolute value shape. I'll test the 5. 5 minus 5 is 0. Is 0 less than 2? It is this time. So I'm going to put a nice big closed circle so I just don't forget that answer. I want my equation on the right-hand side to be the one that would be y equals a positive slope. So that'll be the x minus 5. And the negative slope will be the opposite of x minus 5. Divide this into 2 sections. So using this method then, hopefully you've got this down now, you'd have the opposite of x minus 5 is less than 2, and x minus 5 is less than 2. Solve each. So negative x plus 5 less than 2. Negative x would be less than -3. And dividing by negative is going to switch that sign, so x is greater than +3. This one would be x is less than 7. Okay. Now you got to have that wording memorized. So here we go. In this region right here on the left, I'm asking myself, are there values of x in this region, so to the left of 5, that are greater than 3? Okay, so I'm going to go up and say, yep, 3 is in this region. It doesn't say equal to 3, so I'll make it an open circle. And are there values in just this region that are bigger than 3? Yep, it's going to go from 3 to 5. Okay, all right, the next section over here. Are there values of x in this region that are less than 7? So I go up, I notice 7 is in this region. It's not equal to, so nice big open circle. Are there values just in this region that are less than 7? Yep, it goes to the 5. Okay, and now your answer is going to be the interval or intervals from the number line. I depend on that now. I notice now since 5 is filled in, I'm going completely from 3 to 7, but just not including them. So I can use one interval with parentheses and say my interval goes from 3 to 7. Okay. All right, double absolute value inequalities. Just like we saw when we did double absolute value equalities, okay, when we did equations. Same kind of thing, guys. So notice your critical points that you're going to put on your number line would be 1 and also 3. Okay, so do the best you can to get yourself enough room to figure out what's happening here. So there's 1, there's 3, put my 2 V's on there. Okay, test those 2 points real quick. If you plug in 1, it does work, makes a true statement. If you plug in 3, again, it makes a true statement. Divide it up so that you have 3 regions. Let's put in our equations. So this is going to be the x minus 1 and the opposite of x minus 1. For this one, this will be the 2x minus 6 and the opposite of 2x minus 6. Okay. Remember, on the left side, I'll use both of what's on the left of the V's. On the right side, I'll use what's on the right side of the V's. And in the middle, I'll use what's in the middle between the 2 V's. Okay, so go see if you can replace. Remember this, do this in this order. Okay, so follow that above, what that says, and see if you can write your 3 inequalities. So the opposite of x minus 1 plus the opposite of 2x minus 6 has to be less than 5. And in the middle, you would have x minus 1 plus the opposite of the 2x minus 6 less than 5. And to the right, you would have x minus 1 plus 2x minus 6 less than 5. Okay, carefully solve each one. So negative x plus 1 minus 2x plus 6. Negative 3x plus 7 is less than 5. So negative 3x would be less than negative 2. If I'm going to divide by negative 3, switch that sign and say x is greater than 2/3. All right, here, x minus 1 minus 2x plus 6 less than 5. So negative x plus 5 less than 5. That means negative x can be less than 0. And if I divide by a negative 1, it does change the sign. 0 divided by anything is still 0. And then here, 3x minus 7 is less than 5. So 3x is less than 12, and x is less than 4. All right, let's get ourselves some room and get ready for that wording that we've got to become experts at. So here we go. In this region, are there values of x in this region that are greater than 2/3? Well, 2/3 does happen to lie in this region. I'll put it on here. We don't want equal, so we'll put that. And are there values just in this region? So you have to stay left of the 1 that are bigger than 2/3. Yep, there they are. All right. Now, if I go to the middle region, this one, are there values of x in this region that are greater than 0? Well, notice if I go above, 0 doesn't fall between 1 and 3, so I can't put it in there. However, aren't all the values between 1 and 3 bigger than 0? So you should be shading all of it. Okay, that whole region, everything between 1 and 3 is bigger than 0. And then the last region over here, Are there values in this region that are less than 4? Well, 4 happens to be in this region again, so I put it. I don't want to be equal to 4, so nice big open. And less than 4, just in this region, would stay between the 3 and the 4. Now I completely depend on just the number line to give me my answer. And that answer now, since the 1 and the 3 are filled in, it's literally one interval from 2/3 to 4, not including them. So it looks like it should be parenthesis 2/3 comma 4 parenthesis. Okay. So now let's do this same exact problem that we just did by hand, and let's work with it on the graphing calculator to reemphasize some things and make some connections. So let's check it on the graphing calculator. We're going to use kind of that concept of like when we taught you isect. We're not going to manipulate anything. We're just going to put the left side of the inequality in y1 and the right side in y2. Okay, so if you get to your calculator and go to y equals, in y1, we're going to do that absolute value. Remember, that's in alpha f2. So f2, there's your absolute value of x minus 1. We want to get outside of that, and we want to say plus, again, alpha f2 for your absolute value of 2x minus 6. Okay, and we want to get out of that. Push enter. And then we want y2 to be 5. And we expect y2 to be a horizontal line, right? Okay, because y equals our horizontal lines. We'll go ahead and do a zoom standard, like we've been talking about, 10 by 10 window. All right, so the blue is the part with the absolute values. The red should be the y equals 5. Okay, and if you know if you're counting by ones, that it looks pretty accurate there. Let's make the connections between what was happening with this and with our last problem. So if I take this, and I'll just put it in the file for us. All right, so let's make the connections with what we did by hand. So 1, we should expect them to overlap at our critical points. Okay, and our critical points were at 2/3 and 4. Okay, and I don't mean 2/3 and 4 as being the critical points, but that was our interval where something was happening, right? Because it went from 2/3 to 4. So notice this is at this x value right here that I'm pointing to. That is at x equals 2/3. And this x value that I'm pointing at right there is x equals 4. Okay, so there's where the interval is. Now you would want to know those intersection points. Yes, you could go to your intersection. You can review that. Make sure that you can get that that is an x value of 2/3. That is an x value of 4. But now remember, we're dealing in intervals. So think about this. If you want to know where our equation came up as, I think it says a less than above. So if it's x minus 1 plus 2x plus 6 is less than 5. Well, you're talking about y values. So you're looking for where the absolute value, that's the blue graph, is less than the 5, which is the red graph. Okay, so where are the y values in blue less than the y values in red? And I hope you're going to tell me it would be this entire region. And so you're going to tell me, well, it's not less than at the 2/3 and the 4. It's equal to at the 2/3 and the 4. So less than, you would be telling me x equals between 2/3 and 4, not including them. And notice that is the same thing that we got by hand. Now let's just flip it around on you. What if I had asked you, you would do the exact same work, but what if I had asked you to do the same problem, but make it greater than 5? So now you'd be asking yourself, where is the absolute value? That's the blue graph. Where are those y values greater than 5, which is the red graph? Okay, so where are the y values in blue bigger than the y values in red? Well, hopefully you're going to see this region and this region. So again, you would have to know those intersection points of 2/3 and 4. And then it's going to take two intervals. Okay, that's going to be x equals from negative infinity to 2/3. And again, from 4 to infinity. Okay, there's your interval. And last but not least, just to make the connections, what if I was just asking you, where is the absolute value of x plus 1 plus absolute value of 2x plus 6 equal to 5? Well, the equal should be where they intersect, right? So hopefully you would just be telling me x equals 2/3 and 4. And I guess if you're going to make those intervals, then remember we talked about you would just put brackets around both of them. Okay? All right, so there's your connection with what you did by hand with what we can do on a calculator.